And today we are going to be considering the concept of radioactivity. Now, anytime you hear the word radioactivity, it's talking about the spontaneous disintegration of an unstable atomic nuclei, and which results to the release of either alpha, beta, or gamma radiations, and also with the release of energy. Now, we have a question here, which is a wire question 1994. The question says, in 24 days, a radioactive isotope decreased in mass from 64 grams to uh, 2 grams. That shows that it is even unstable. What is the half-life of the radioactive material? Now, what we're going to do is this. The question is centered on what is the half-life, centered on half-life. So what we're going to do, we will look for the number of half-lives that we're going to have in 24 days for this radioactive isotope to reduce from 64 grams to 2 grams. And let me take it again. We're going to look for the number of half-lives that we are going to have in 24 days for this radioactive isotope to reduce from 64 grams to 2 grams. Now, how you do this is simply by dividing the first mass given to you here. We're going to keep dividing this mass by 2 until we get to 2 grams, calculating the number of half-lives. Now, the first division by 2 will give us the first half-life. The second division by 2 also give us the next half-life. That is how until we get to 2 grams. Now, this is what I mean. We're going to have the first one. We will say 64 grams divided by 2 will give us 32 grams, which is equal to 1 half-life. The next one to be 32 grams divided by 2. This will give us 16 grams, which is second half-life, our number 2 half-life. The next one will have 16 grams divided by 2, which will give us 8 grams, which is our third half-life. Then next we'll have 8 grams divided by 2. 8 grams divided by 2. This will give us 4 grams, which is our fourth half-life. The last one will have 4 grams divided by 2. This will give us 4 divided by 2 give us 2 grams, which is our fifth half-life. Fifth half-life. Now, we're stopping here because it reduced in mass from 64 grams to 2 grams. So we're stopping here. Now, if you check the number of half-lives, we have 1, 2, 5. So there are 5 half-lives. So 5 half-lives will take 24 days. So we'll have 5 half-life will give us 24 days. Meaning it will take 5 half-lives for this radioactive isotope to reduce from 64 grams to 2 grams in 24 days. So 5 half-lives will give us 24 days. Now, we'll compare with 1 half-life. Then 1 half-life will give us how many days? Now, we use T as a conventional representation of this. So 1 half-life will give us T. Then we'll cross multiply because we're given the number of days to take for 1 half-life. When we cross multiply, that's 5 times T. We have 5 times T, which is equal to 1 times 24 to give us 5T equals 24. Now, we're looking for T. We divide both sides by 5. So we have T will give us, this 5 cancels 5, we have T left here. So T equals 24 divided by 5. That will give us 4.8. So 4.8 days. So The question is clear. What is the half-life of the radioactive material? So what we're going to get, the answer is going to be 4.8 days. So one half-life will give us 4.8 days. This is the solution to this question. Now we're going to also look at more questions, but subscribe to get more of these questions. We have more of this, so please, you do us good by subscribing to get more of these solutions to some of these questions. Thank you for watching.